Hello, this is Dr. Kennedy. I'm here today to try to give you an example of how to do a one-way ANOVA. We're going to walk through the PowerPoint example that we didn't get to in class. This one is comparing three different groups, and again we're using an ANOVA instead of a t-test because we're comparing, again, more than two groups in this case. So the first thing that you need to do, I've worked out the table. Again, the main difficult calculation part of doing one of these problems is just setting up the table and having all your different groups calculated and worked out. So again, we had three different groups from the PowerPoint, and all I've done here is gone through and added up each of the columns. So as you can see, we have a sum of x. The little subscript here represents each of the different groups. So all I've done is gone through and added up all of the different x values, and then of course we have an x squared column for each of the different groups, and all I've done again is gone through and squared each value. And so down here we should have a sum of x squared for each of the three groups. Okay, the thing that is new for this problem that we haven't talked about before is, in this case, we have a sum of x total and a sum of x squared total. And all you do to get those terms is first calculate the sum of x for all of those different groups, and then you just go through and add them all up. So 80 plus 67 plus 82 gives you 229. And then sum of x squared total, you do the same thing. So 1082 plus 755 plus 1132 gives you 229.69. Okay, so this is the vital new information that you don't do with the t-test that you do need to do with an ANOVA. And you should be aware that each of the different groups has a different small n. In this case, small n is the same for all of them. There's six people in each of the different groups. And we have a separate big N, which is the total number of subjects we have overall. So in this case, we have 18, N equals N 18. So this is the main table that you need to set up to be able to do the different equations. And again, doing a one-way ANOVA is mainly a long process because you have lots of different equations that you have to keep track of. So we're going to go back over here to the PowerPoint. Okay, so the first thing you need to do in calculating a sum of squares table for ANOVA is get the sum of squares total. And all you're doing here is plugging in, again, the values that we've calculated. Bear with me. So we have sum of x squared total is 2,969. Sum of x squared total is 229. And we're just plugging that in just the same way we've done all along, basically, and we just have different values in this case. So the 229 we're plugging in here, squaring it, dividing it by big N, which again is 18. So, and then we calculate this side, subtract it from 2,969, and that gives us 55.611. Okay, and then after we have that, the next step is to calculate the sum of squares between. Again, this equation looks a little bit scary, but it is actually not so bad. All this is doing, or asking you to do, is find the sum of x in each column, square it, and then divide it by the number of people in that column. And then again, the sum here is telling you to add all of those things up. So that's what we're doing down here. So we get sum of x, for group 1, which is 80, square it, divided by little n, so there are 6 people in that column, and we're doing that for each of the three groups. Okay. This term over here is different in that we're taking the sum of x total, squaring that, and dividing it by big N, in this case is 18. Okay, so in order to calculate this, again, order of operations, you want to go through and basically write out the answers for each of these. Square 80 divided by 6. Do that for each of these. Square 229 divided by 18. subtract it, you should end up with 22.111. Okay, so again, this is just a matter of plugging things in to the equation and doing them in the right order. Once you get that, you should end up with 22.111. Okay, so now what do you do? Once you have those two values, you need to find the sum of squares within, and all you're doing is subtracting those two values that you have just calculated, okay? So in the first step, we calculated sum of squares total. We just calculated sum of squares between. All we do is subtract the two, and we end up with 33.5. Okay, so what's all this? So in this case, we have different degrees of freedom for each of the different between, within, and total in this case. And again, I mentioned in class last time that k, little k in this case, represents the number of conditions that you have. So in this case, we have 3 groups or 3 conditions. So degrees of freedom within is 3 minus 1 or 2. Degrees of freedom within is big N, so total number of subjects, minus the number of conditions gives you 15. And then finally, the degrees of freedom for the total is 18 minus 1, total number of people you have minus 1 is 17. Okay, so you calculate all that, and you're filling in that sum of squares table for an ANOVA with all these different values. Okay, so what do we do with all these things that we've calculated? Once we have them, all we do is go through and, again, plug things into these 3 different equations. All right, so the F equation is built up, again, of mean squares between, mean squares within. And in order to get those, though, we have to go back up here and divide the sum of squares for these different between and within by the appropriate degrees of freedom, which we just calculated. Okay, so it's just a matter, again, of plugging things in and just many steps. So sum of squares between we calculated before, 22.111, divided by some degrees of freedom between, which is 2, we end up with 11.055. Mean squares within do the same thing. We already calculated sum of squares within, divided by its own special degrees of freedom, gives you 2.233. And then finally, all of this to get you to the F equation. So this is what we're actually trying to calculate from doing these many steps, is to get an F value, which tells us whether or not our ANOVA is significant or not. Okay, so we've calculated these different steps. All we're doing is plugging, once again, these values in down here. So 11.055 divided by mean squares within, we end up with an overall F value of 4.951. Okay. So what does that value mean? We end up with that. Finding your critical value in the table is a little bit different for ANOVA, because in this case you have to deal with 2 different degrees of freedom. Okay, so we're using the degrees of freedom, we'll go back here, between, and we use up the degrees of freedom within. So in this case 2 and 15 we look up in the table. I unfortunately don't have the table right here to show you. Maybe I do. Bear with me. Let me see if I can find the table. So the main difference, again, okay, let me see what happens here. With the F, I'm not sure if this is going to show up because it's really small. At the top, you have degrees of freedom between groups. I'm sorry, it's out of focus. And on the left, you have degrees of freedom within groups. And so all you do is you find, again, based on your alpha level, you can use 0.05 in this case. You find the top value based on the degrees of freedom between groups, and then on the left, degrees of freedom within groups, and then you go down in the center, and again, try this out for yourself. Look at the table, but using degrees of freedom of 2 and 15, you end up with a critical value of 3.68. Okay, and so again, just like all the other tests we've calculated, we're comparing the obtained value to that critical value, And so since 4.951 is more extreme than 3.68, we say that we do have a significant F value, we do have a significant ANOVA. So if you remember from last time, I mentioned that when you have a significant ANOVA, it just tells you that there's a difference between your groups somewhere, but it doesn't tell you where that specific difference is. Is it between group 1 and 3? Is it between group 1 and 2? We don't know until we do what's called a post hoc test. I think I will save doing the post hoc test until next time. For right now, I just want you to have the basic understanding of how to calculate the overall F value, and in class next time I will go through how to calculate a post hoc test. But it's important that you keep in mind that you would only do a post hoc test if you have a significant F value. If it turned out that our F value right here was not significant, we would just stop and say that there's no significant difference anywhere. But in this case, we would go on and try to figure out where exactly the difference is between our groups. So I'm hoping that this is enough of an example to be able to help you out to do your practice problem. If you have any questions about how to do this, feel free to email me and I will help step you through.